In this section, we'll look at more problems that involve determining whether two lines are parallel, perpendicular, or neither. We say two lines are parallel if they don't intersect anywhere and they're two different lines. Graphically, we represent parallel lines as follows. So here's our first line, f of x, and here's our second line, g of x. Then, by definition, we say two lines are parallel if and only if they have the same slope. A complementary concept to parallel lines is perpendicular lines. Two lines are perpendicular if they intersect at one point and their intersection is a right angle. Let the blue line be called f of x, then pictorially a perpendicular line would look like the following, where the red line is g of x and their angle of intersection is 90. By a stricter definition, we say two lines are perpendicular if and only if the slopes of these lines are negative reciprocals of each other. Let's go ahead and try an example where, given two lines, we want to determine if they're parallel, perpendicular, or neither. Again, we're given two lines, and the idea of parallel and perpendicular lines are defined in terms of slope. So we need to find the slope of line number 1 and line number 2. The easiest way to do this is to put this into slope-intercept form, which means we need to solve both of these equations for y. Let's start with line number 1. Solving this equation for y, we need to subtract 3x from both sides, and we're left with 2y is equal to a negative 3x plus 10. Divide both sides by 2, and we'll get y is equal to negative 3 divided by 2, x plus 5. We see in this case our slope is given by a negative 3x divided by 2. Now let's find the slope for L2. L2 is given by negative y is equal to 18x plus 2. Multiply both sides by negative 1, and we get y minus 18x minus 2. Here we see the slope of this line is given by negative 18. We see that negative 3 divided by 2 is not equal to negative 18, so these lines are not parallel. And if we look at the negative reciprocal of negative 3 divided by 2, this is not equal to the negative reciprocal, of 1 divided by 18. So these lines are neither parallel or perpendicular. Let's try one more example. Example number 5. Find an equation for a line that goes through the following 2 points, and also find an equation for a line going through these 2 points. Then determine if they're perpendicular, parallel, or neither. We'll call the line that goes through the points 2, 1, and 2, 3, L1, and we'll call the line that goes through the points 4, 6, and negative 1, 1, L2. Let's go ahead and find the equation for L1. To do this first, we need to find the slope of this line. Again, the slope is given by y2 minus y1 divided by x2 minus x1. Then up top we'll have 3 minus 1 divided by 2 minus 2. Here we'll get 2 divided by 0. What this tells us is that the slope of our line is undefined. So our line has an undefined slope, which means this line is a vertical line. And the equation of a vertical line is given by x is equal to some constant c. And in this case, since our x values don't change from 2, the equation is going to be x is equal to 2. Now let's go ahead and find the equation for line number 2. First, we'll start with the slope. Remember, the 2 points that this line goes through are the points 4, 6, and the point negative 1, 1. calculating the slope in this case, we'll get 1 minus 6 divided by a negative 1 minus 4. Up top, this becomes a negative 5, and on the bottom, this also becomes a negative 5. Then the slope of this line is given by 5. Since we have a point and we have the slope, we can just put this in point slope form, which will be y minus y1 is equal to m times x minus x1. So this is going to be y minus 1 is equal to 5 times x minus a negative 1. Then the equation for this line will be y minus 1 is equal to 5 times an x plus 1. Here we have the slope of L2 is 5. The slope of L1 was undefined, which means that since 5 is not equal to undefined, this implies that our lines are not parallel. And since 5 is not equal to the negative reciprocal of undefined, these two lines are not perpendicular. So the second answer to our question will be neither.